Okay, we're going to look at solving a value mixture problem using linear equations. So we have a word problem here about two cars in a family. And so we're going to label them, and we're going to label that X, we're going to talk about the number of gallons of gas in car 1, and Y is the number of gallons of gas for car 2. Also, if we want to know how far the cars travel, the number of gallons of gas times the miles per gallon will give us the number of miles each car traveled. So the first part of this, they give us a lot of information here. So we know that first they traveled a combined total of 1775 miles. And remember that we find out how far they traveled by looking at the number of gallons times the miles per gallon. So I'm going to take the miles per gallon times the number of gallons of gas for car 1, do the same with car 2, and that should equal the 1,775 miles. The next part of information that we have is that there was a total gas consumption of 50 gallons. So X plus Y must be 50. Now we're down to just solving the system. And the easiest thing to do, I think, is to take that second equation and solve it for a variable. I chose to solve it for Y. You could solve it for X if you prefer. And now that I know an expression for Y, I'm going to go plug it in up there where the Y is. So now I've got it set up. I've got to distribute this 50, right? So there's the result of the distribution. Now I need to subtract 2,500 from both sides. And also notice that I have some like terms there that I combine. So when I do that, my result is negative 25x is negative 725. Dividing both sides by negative 25 tells me that x is 29. So now that I have the 29, I can go into my equation I solved for y and replace x with its actual amount. So plugging in a 29 for x gives me that y is 21. So my car 1 had 29 gallons and car 2 had 21 gallons. Let's look at one more. So here we have a family using their sprinklers. We know the water output rate for each sprinkler, and we know that they use them for a total of 60 hours, resulting in a water output of 1,300. So I'm going to let T be the number of hours that the Tran sprinkler ran, and R be the number of hours the Reed sprinkler ran. So it says they ran for a combined total of 60 hours. So T plus R equals 60. If you don't like T and R, you can use X and Y. It doesn't matter. Now, I want to think about how much water output it is. So let's think about that. Water output is going to be the rate the water flows times how long it was out, right? So we know that the Tran family was 20 liters per hour and Reed was 25 liters per hour. So we end up with 20T plus 25R is 1,300. And then we, just like the last one we did, the easiest thing to do is to go up to that first equation and solve for one of the variables. It does not matter which one, I chose T. Now that I have an expression for T, I can go into my green equation and replace the T with its value. Now I've got to distribute that 20. There's the result of that. I want to subtract 1,200 from both sides. And I also have some like terms that I can combine. So I end up with 5R is 100, so R is 20. Now that I know what R is, I'm going to go back up to my blue equation and replace R with its value, which tells me that T is 40 hours. So that means that Tran ran the sprinkler for 40 hours and the Reed family ran the sprinkler for 20 hours. I hope you find this helpful.